Want to unlock the hidden potential of any AI model? I'm talking about making them more accurate, better at reasoning, and faster, without changing a single line of their core code. And we're not just talking theoretical improvements. This is a technique so powerful, it's being used in cutting-edge models like O1. Sounds too good to be true? Stick around, because I'm about to reveal the secret weapon that's changing the AI game. And the secret weapon I'm talking about is called test-time compute, or as some people call it, inference-time compute. That just means when the AI is answering a question, or even just reasoning time. It's all about giving AI more time to think. In this video, you'll learn what it is, why it works, and how you can use it today to boost your AI's performance, no matter how big or small it is. Okay, so what is test-time compute, and why does it even work? Simply put, it's about giving your AI extra processing time after it's been trained. It's like giving it a mental scratch pad, a chance to deliberate. It's important to understand this is different from test-time training, which involves actually changing the model. We're not doing that here. We're working with the model as is. Most AI improvements focus on training, feeding it more data, making it bigger. But test-time compute is different. It's about making the AI more insightful with the knowledge it already has. We're not adding new information, we're unlocking the potential within. To really understand this, let's use an analogy. Think of it like this. Imagine a student taking a test. Training is like studying. Test-time compute is like giving that student extra time and allowing them to work out the problem. Imagine the student frantically scribbling equations, crossing them out, trying different approaches on their scratch paper. That's the kind of extra effort we're giving the AI. It's about applying knowledge more effectively, not just accumulating it. AI models, even small ones, have a ton of knowledge packed inside. In fact, researchers have shown that even models with just a few billion parameters, tiny compared to the giants, can see dramatic gains with test-time compute. But when you ask them a question, they usually just give you the default answer, the first thing that pops into their head, so to speak. Test-time compute allows the AI to consider alternatives. In other words, it lets the AI consider different definitions of words, try different mathematical formulas, or even explore different writing styles to reason more thoroughly. So essentially, it's not just picking the first response, it's breaking the problem down, checking for inconsistencies, and comparing solutions. It allows the AI to tap into knowledge that might not be on the obvious pathway. It's like a human working through a problem on paper. We don't always get the right answer immediately, do we? We try different approaches, we make mistakes, we learn. Test-time compute lets AI do something similar. And importantly, it helps with the black box problem. One of the biggest criticisms of AI is that we often don't know how it arrives at its answers. Test-time compute, especially techniques like chain of thought, help open up that box and make the AI's reasoning process more understandable and transparent. Have you ever had a time when giving your own brain a little bit of extra time made a difference? Let me know in the comments below. Okay, let's get practical. How can you actually use test-time compute? There are several techniques, and we'll cover the most important ones for beginners. The simplest method is called best of N sampling. It's like asking the AI the same question multiple times, but with a little bit of randomness thrown in. It's like brainstorming multiple ideas quickly before choosing the best one. This randomness is controlled by something called temperature. Think of temperature like rolling dice. A low temperature is like rolling a weighted die. It almost always lands on the same number. A high temperature is like rolling a fair die. Any number is equally likely. High temperature means more randomness, more diverse answers. Low temperature means more predictable answers, closer to what the AI initially thinks is best. Then, you simply pick the best answer out of the bunch. Now, let's move on to another technique. Chain of thought prompting. This is like asking the AI to meticulously work through a problem, step by step. Instead of just asking for the answer, you ask the AI to explain its reasoning step by step. It's like asking it to think out loud. As the AI explains its reasoning, it can often catch its own mistakes and correct them. It's a form of self-critique. Now, for those of you who want to take things to the next level, there's a technique called using verifiers. Think of these as AI evaluators that can check the AI's work. It's like having an editor or proofreader for your AI. A verifier can look at an answer and say, "This looks good," or "This looks bad." It's like having a built-in fact checker, but it doesn't guarantee correctness. Now, there are two main types. A basic one, called an outcome reward model, just checks the final answer. But a more advanced type, called a process reward model, can actually check each step of the AI's reasonings. What do you think about these methods? Which one of these methods do you think is the most powerful, and why? Let me know in the comments. Now, before you get too excited, it's important to remember that test time compute isn't magic. There are some trade-offs. First, and most fundamentally, test time compute can't give the AI knowledge it simply doesn't have. It's not about creating new information, it's about using what's already there more effectively. It also does not necessarily lead to better performance if not implemented correctly. Second, cost. More computation means more time, and potentially more money, depending on how you're accessing the AI. Beyond the cost, there's also response time. If you need an answer immediately, test time compute might not be the best. But for many tasks, a few extra seconds or even minutes can be worth it for a much better answer. Think of it like a deep thinking mode. And finally, even verifiers can make mistakes. They're AI models too, and they can be tricked. It's possible for the AI to find ways to exploit the verifier, giving answers that look good to the verifier, but aren't actually correct. You might be thinking, okay, if this makes things cheaper per computation, won't we just spend less overall on AI? That's where Jevons paradox comes in. It basically says that when something becomes more efficient, we tend to use more of it, not less. Think about the old incandescent light bulbs. They wasted a lot of energy as heat. More efficient bulbs didn't lead to less light. They led to way more light everywhere. The same is likely to be true for AI. While there's a cost per query, test time compute could actually reduce overall costs in the long run by letting you use smaller, cheaper models without sacrificing accuracy. And because it's more efficient, we'll likely use AI for even more things. Just like with light bulbs, cheaper and better AI means we'll find more ways to use it, solving problems we couldn't even imagine before. And if you're hungry for more, look out for the next video. We'll explore advanced test time compute techniques, including those AI evaluators, and how to push AI reasoning even further, including a look at how models like O1 are using these techniques. So make sure you subscribe. What kind of AI tasks do you think would benefit most from test time compute? Let me know in the comments. Want to unlock the power of AI? Our free newsletter gives you the tips, trends, AI news, and tools you need to succeed. Sign up with the link in the description below. Your journey doesn't stop here. Watch our next video right here and keep building your knowledge.